Hello, this is Mr. Ensler, and I'm going to be going through the Chapter 3 Geometry review in preparation for that test. So here, in this first example, we have this diagram. It's our classic diagram of two lines cut by a transversal, and we have 8 different angles created here, and all of these angle pair names. These are all angle pairs. And you have to be able to tell which angles fall into which named categories. So number 1, we're talking about vertical angles. This is actually a type of angle that we learned earlier in the year. Vertical angles are across the x from each other. So angles like 1 and 4 are vertical, 3 and 2, 5 and 8, and 7 and 6 are vertical. We also know that vertical angles are congruent to each other, and that's true whether the two lines are parallel or not. Vertical angles are always congruent to each other. That was theorem 2.6. Alright, next up, number 2, we have corresponding angles. Corresponding angles, if you look up this on postulate number 15, it just says that they're angles in corresponding positions. They're going to be on the same side of the transversal as each other. One's going to be on the inside, one's going to be on the outside, and they're usually going to look like they're about the same angle measure. So corresponding angles would be angles like 7 and 3, 5 and 1, 8 and 4, and 6 and 2 are corresponding. Corresponding angles might have the least descriptive name. The best way to learn corresponding angles is just to memorize those positions of what that looks like. Alright, next up, alternate interior angles. Here we can learn a little bit from the name. Alternate means they're on different sides of the transversal. One would be on the left side, one would be on the right side. Interior means that they're in the middle. So the alternate interior angles in this diagram would be 5 and 4 and 3 and 6. Alright, number 4, consecutive interior angles. Consecutive means that the angles are right in a row, and interior means they're both on the inside. So 5 and 3 would be consecutive interior, 6 and 4 would be consecutive interior. Alright, and then number 5, alternate exterior angles. So alternate, again, that means one angle is going to be on the left side of the transversal, one will be on the right. Exterior means these outside angles, 1, 2, and 7, 8. So alternate exterior angles would be 7 and 2 and 1 and 8. Alright, and so that's what we learned in lesson 3.1. That's really the foundation for this whole unit, is knowing these names of different angle pairs that we have when two lines are cut by a transversal. The next thing that we learned in Unit 3 is that when we have the situation of two lines being cut by a transversal, if those two lines are parallel, then some of these types of angles will be congruent and some of them will be supplementary. So let's just review that real quick here. Vertical angles are always congruent, but if two lines are parallel cut by transversal, corresponding angles will be congruent, alternate interior angles will be congruent, and alternate exterior angles will be congruent. Consecutive interior is the oddball. Those will not be congruent, those will be supplementary. Those two angles will add up to 180. And again, all of these things are true if the two lines are parallel. So let's take a look at number 6 here. We do have two parallel lines, and we have alternate interior angles. And so what we just reviewed is if two lines are parallel, alternate interior angles will be congruent. So we just set them equal. 3x equals 75. Divide both sides by 3, and we get our answer, x equals 25. Alright, going over to number 7. These angles also have a name. These would be alternate exterior angles. And so if two lines are parallel, like these, then alternate exterior angles will be congruent. So we're going to set them equal to each other. And then we'll just solve this. I'll subtract 5, and then divide by 4. So x will equal 33. Alright, in number 8, these are consecutive interior. That's the kind that if two lines are parallel, they're going to be supplementary. They're going to add up to 180. So you absolutely have to remember the difference between which angles are congruent and which angles add up to 180. So I'm going to add these, and together they will equal 180. All right, 80 and 20 on the left side here makes 100. If you take away 100 from both sides, I get 5x equals 80. So then we'll divide by 5. And 80 divided by 5 is 16. All right, number 9. These angles are also consecutive interior. And so since the two lines are parallel, consecutive interior angles are supplementary. They're going to add up to 180. So we'll set that up. 130 plus 2x minus 70. You could add them in either order. If I simplify this left side, 130 and minus 70, that gives me 60. And then I'm going to subtract that 60 from both sides. So 2x equals 120, divide by 2, and x equals 60. All right, on the next page, we're just continuing on with solving. So number 10, we have two parallel lines cut by a transversal. These are vertical angles. So actually, even if these lines weren't parallel, these angles would still be congruent. We're going to set them equal. And this is kind of a simple example because when you set them equal, it's all done. You have your answer. In number 11, the two angles are alternate interior. And since the two lines are parallel, alternate interior angles will be congruent. So we'll set those equal. Another one that's just, you get the answer right when you set it up. Number 12, we have two parallel lines cut by transversal, and these are consecutive interior. That's the oddball one. Those are not going to be congruent. Those are going to add up to equal 180. So then I would subtract 120 from both sides, and we get x equals 60. That would be our answer. All right, then number 13, we do have two parallel lines cut by transversal. These are alternate interior angles, and so those will be congruent. So we'll set them equal to each other. I would add 22 to both sides. So I get 72 equals 18x. Divide both sides by 18, and it does work out evenly to 4. Alright, in the next set of problems, determine if the lines are parallel, perpendicular, or neither. So this is some of the last things we are studying in this unit. What we have to do is figure out the slope of each of these lines. And in this first set of examples, we should know the slope just by looking, because this is in y equals mx plus b form. If you remember from algebra, when an equation is in y equals mx plus b form, the m is the slope. And we know parallel lines have the same slope, perpendicular lines have opposite reciprocal slopes. So in 14, these slopes are not the same. They're not opposite reciprocal either. They are reciprocal, but to be opposite, one would have to be positive, one would have to be negative. So for this one, we would just say neither. You don't really need to show any work for these because the slope is basically given if you know where to look. Number 15, see those slopes are both. And number 15, see those slopes are both the same. They're both 3. That means these lines are parallel. In number 16, we have a slope of 2 and of negative 1/2. Those are opposite reciprocals. If you think about 2 as 2 over 1, and the other slope is negative 1/2, this is a great example of opposite reciprocals. Opposite means one's positive, one's negative. Reciprocal means they're flipped, they're multiplicative inverses. So these lines are perpendicular. All right, in number 17, I have negative 2 and 2. So they're not parallel because they're different slopes. They're not perpendicular either. They are opposites, but they're not reciprocals. So this would just be neither. These lines, they're not parallel, they're not perpendicular. They're going to cross at some point, but they're not going to cross perpendicularly. All right, number 18, we got a slope of 2/5 and 2/5. Those would be parallel, same slope. And number 19, slope of -3 and positive 1/3, those are opposite reciprocals. If you think of this as -3/1 and positive 1/3, they're opposites because one's positive, one's negative, and they're reciprocals because they're flipped. So those would be perpendicular. All right, now we're going to be finding the slopes of the line that passes through these points. So you can use the slope formula, y2 minus y1 over x2 minus x1. So if I apply that formula to number 20, so the slope here, and we call slope m, we're going to do y2 minus y1 over x2 minus x1. If it helps you, feel free to label these points. Like this would be x1, y1. This point would be x2, y2. So if I wanted to do y2 minus y1, that'd be -3 minus 7 on top, and on bottom, -1 minus 2. So on top, that's -10. On bottom, that's -3. A fraction that's a negative over a negative is actually positive, so you should simplify that. And your slope is 10/3. That means this line is rising, it's going up. So that's what we get. All right, for number 21, let's do the same thing. For the slope, I'll do 4 minus -1. Make sure you don't just write down 4 minus 1. And on bottom, 3 minus 3. So 4 minus -1, you're actually going to add those, and you get 5. On bottom, you get 0. All right, now, anytime in math that you're trying to divide by 0, well, you can't. That idea doesn't make sense to us. You can't divide by 0, and so what you have to write here is undefined. Trying to divide by 0, it just doesn't make sense. It's not defined. It's undefined. So don't leave your answer as 5/0. Definitely don't put down 0. One clue that sometimes students use to remember this is if you type in 5 divided by 0 into your calculator, it will say error divide by 0, and that's because it's undefined. You can't divide by 0. All right, let's look at number 22. And in number 22, if I have my x1 and y1 and x2 and y2, I just want to show you that you can also do slope going in the other order. For instance, I could do y1 minus y2. 5 minus 12. I still got to do my y on top and x on bottom. And if I do that, then I got to start with 0 on bottom minus -6. So you can do that too. It's kind of up to you. I'll get -7 over +6. All right, so that's my slope. This line is going down. It's falling or it's decreasing. Let me go back to number 21. This undefined slope line is a vertical line. It'd be very helpful for you to know that. All right, number 23. I'll do on top 1 minus 1. On bottom, I'll do 5 minus -3. So I'm going to get 0 over 8. Or if you did it the other way around, you'd get 0 over -8. Either way, 0 divided by a number equals 0. All right, so the slope is 0. This means that this is a horizontal line. So if you ever get undefined and 0 mixed up, use your calculator to help it. If you actually type in 0 divided by 8, it will tell you that the answer is 0. If you do 8 divided by 0, it'll say undefined. All right, so in the next set of problems, we're going to be finding slopes still, but then we're going to be using that slope to compare the given lines. So let's look at number 24 here. And we got line 1 and line 2. So let's find the slope of line 1. Line 1 passes through these points. So I'm going to do 10 minus 7 and 9 minus 4. So the slope of this first line is 3/5. Now let's find the slope of the second line, line number 2. I'll do 14 minus 4 on top, 6 minus 0 on bottom. And so I get 10 over 6. And reduce that, you get 5/3. And so we're supposed to tell, the directions say, tell whether the lines through the given points are parallel, perpendicular, or neither. And if I look at these two slopes, they're not the same, so they're not parallel. They are reciprocals, but they're not opposites. They're both positive. So this would be an example of the two lines being neither. Those lines will cross at some point, but they're not perpendicular, and they're definitely not parallel. Alright, number 25. Line number 1, if I set up the slope for this, I'll do 4 minus 2 on top, 5 minus 1 on bottom, and I get 2 over 4. You should reduce that to 1/2. Line number 2, I'm going to do 9 minus 8 on top, 9 minus 7 on bottom, and I get 1 over 2. Hey, look at that. We have the same exact slope. That means these lines are parallel. Alright, number 26. Let's figure out the slope of each one of these. So I'm going to set this up 5 minus 2 on top, 9 minus 5 on bottom, and I get 3/4. For line 2, I'll do 6 minus 2 on top and 0 minus 3 on bottom, and I would get 4 over negative 3. So let's take a look at these two slopes. They're definitely not parallel. They are opposites because one is negative, one's positive, and they're also reciprocals. Notice one is just a flipped version of the other. So this is what it means to be opposite reciprocals, and you need to know that that's what perpendicular lines have slopes of, opposite reciprocal slopes. Alright, number 27, let's just keep on going here. Line number 1, I'm going to do 3 minus negative 1 over 7 minus 7. So that's going to be 4 over 0. Oh, so that means this is undefined. It would very much help you to know that that means this is a vertical line. And line number 2, on top I'll do 2 minus 2. On bottom I'll do 8 minus 5. I get 0 over 3, which is just 0. Now, when you compare these two, you know they're not the same slope, so they're not parallel, but are they perpendicular? It doesn't look like they're opposite reciprocals, but you got to remember that a slope of 0 means that this is a horizontal line. And we definitely know that a perfectly horizontal line and a perfectly vertical line are going to be perpendicular to each other. So this is kind of a special case where you just have to know that vertical and horizontal lines are always perpendicular to each other. Alright, number 28, let's just keep it going. Line number 1, I'm going to do 7 minus 5 and 5 minus negative 1. So that's going to be 2 over, I know 5 minus negative 1 is really plus, so that's 6. Reduce that to get 1/3. Always reduce your slope, simplify it. Line number 2, I'll do this one in the opposite order. I'll do 1 minus 0 on top, 8 minus 5 on bottom. I just think that's the easier order to do this one in. So I get 1 over 3. Hey, look at that. We have the exact same slope, and so that means these lines are parallel. Alright, number 29, last one of these. So for line number 1, I'll do 9 minus 7 on top, 8 minus 2 on bottom. I get 2 over 6. That's also 1/3. For line number 2, I'll do 7 minus 1 on top, 3 minus 1 on bottom. I get 6 over 2, and that's a slope of 3, or 3 over 1. So those are my two slopes. They are reciprocals of each other, but these are not perpendicular, because perpendicular lines have opposite reciprocal slopes, and these aren't opposite. So these lines are neither. They're not parallel, they're not perpendicular. Alright, so on this page we're going to be writing equations. This was one of the very last things that we learned. And you can use regular old y equals mx plus b slope-intercept form. You can also use point slope form. Y minus y1 equals m times x minus x1. You can use whichever one you want. I'll probably use a variety of both. But in a case like number 30, where we're going to write it and we're going to end in slope-intercept form would be this form. Since all you really need to write an equation is the slope and the intercept, look at number 30. They're giving us both of those. So all we have to do is just plug that in. This is going to be y equals 2/3 x plus 7. We know that m is the slope and b is the y-intercept. So there's my answer. Number 31, they don't give us that directly. They give us the slope. So it's like I know my final answer is going to be y equals 2x something but I don't know what the y-intercept is. And so that's where you're going to plug this information into one of the two equations. So how would you plug this into y equals mx plus b form? Well, what you would do, let me just show here, y equals mx plus b. Our point 5, 3, that's like an x and a y value. So I'm going to put 3 in for y. I know the slope is 2, x is 5, and what I don't know is my b, my y-intercept. If I knew that, then I could just put that in and I'd have my answer. So now let's just go ahead and figure out what this equals. 3 equals 10 plus b, and then you want to subtract 10 from both sides, and so b equals negative 7. So my answer is going to be y equals 2x minus 7. Alright, number 32. Same kind of information here. We know the slope, we know a point, so I know my answer is going to be y equals 1/2 x something. I just don't know what that y-intercept is. Let's use point slope form this time. You know, y minus y1 equals m times x minus x1. And that y1 and x1, that's just the ordered pair. That's the 2 and the 7. The y and x, that's just the regular y and x that we're going to end up with in our answer. Alright, so zoom in a little here. When I use point slope form, 2 is my x and 7 is my y, and of course my slope, m, is 1/2. So I'm going to do y minus 7 equals 1/2 times x minus 2. Notice those minus signs are built into the equation, so even though this is positive 2 and 7, when I put them in the formula, those minus signs are already there. They're already in the formula. Alright, what I would do next is leave the left side alone for a moment and distribute that 1/2. So 1/2 times x is 1/2 x. 1/2 times minus 2 is minus 1. Then add 7 to both sides, that way this 7 goes away. And I'll have y by itself, and my answer will be y equals 1/2 x, I already knew that, plus 6. So 6 is my y-intercept. Alright, 33. Now in 33, we don't know the slope, so before you do anything, let's figure out the slope. I'll do 5 minus 4 on top, 6 minus 3 on bottom, and I get 1/3 as my slope. Now you have a lot of choices. We have to pick one of these points to use. You really don't need them both. So pick one of them. It doesn't really matter which one you pick. I'll just pick this one. It comes first. And then you can pick either method of doing this. If you want to do this using slope-intercept form, y equals mx plus b, that's fine. Or you can use point slope form, y minus y1 equals m times x minus x1. So I'll show you this both ways. And I'll use this 0.34, and I'll use my slope of 1/3. Alright, so if I'm going to plug this into slope-intercept form, it's going to be 4 equals 1/3 times 3 plus b. I don't know what b is. It's like I know my final answer is going to be y equals 1/3 x and then something. I don't know what this last part's going to be. Alright, so 4 equals 1/3 times 3 is 1, and then I'll subtract 1 from each side, and so it turns out that b equals 3. So my answer is going to be y equals 1/3 x plus 3. And just to show you, this will also work if you use point slope. I could do y minus 4 equals 1/3 times x minus 3. And I'll leave that y minus 4 over there for a moment and distribute the 1/3. So we'll get 1/3 x. 1/3 times minus 3 is negative 1. We'll add 4 to both sides. And of course we get the same answer. Y equals 1/3 x plus 3. So it works either way. Alright, let's do some graphing. So in these next few problems we're going to graph a line. And you got to remember that the number right next to the x is your slope. This number, 2, over here, is the y-intercept. It's your starting point. So I would start at 2 on the y-axis. We got the y-axis and the x-axis. So start right here at 2. And then this slope of negative 2/3 tells me that I'm going to go down 2 and over 3. So from there I'll go down 2 over 3, make another little dot there. Why don't you go ahead and do that again, down 2 over 3, and make a dot right there. The more dots you have, the better line that you're going to draw. So really I could also go up 2 and left 3. I could do the opposite and go up 2 and left 3. I could do it again, up 2 and left 3. I would do as many times as you can. That way you can draw as straight of a line as possible. Alright, now you should use a straight edge. I really can't use a straight edge on this program that I'm using, so you have to forgive me that my lines are not very good. But you should definitely use a straight edge when you do this. Alright, number 35. Looks like my y-intercept is -4. So I'm going to start down here at -4. My slope is 3, or if you want to think of it as 3 over 1, that means you're going to go up 3 and over to the right 1. So up 1, 2, 3, over 1, we'll put it right there. Let's do that a few more times. So up 1, 2, 3, over 1, up 1, 2, 3, over 1. And there you go. You can see what your line is going to look like. So you want to take a straight edge. Whew, that's not a very good line at all. And you want to connect those dots. Alright, number 36. Looks like we're starting at -3. And I have a slope of positive 1/2. Remember what we learned. If it's a positive slope, the line will be going up. If it's a negative slope, then the line will be going down. So that's why in 34, the line's going down. 35, we have a positive slope, the line's going up. 36, we have a positive slope, this line will be going up also. So up 1 over 2, up 1 over 2, up 1 over 2. I can even go back the other way and go down 1, left 2, down 1, left 2, down 1, left 2. That way you kind of have all the dots you can fit on there, and that's going to help you draw a straighter line. Make sure that your line extends the whole graph and that you put arrows. Lines, we know, keep going in both directions. They have arrows. Don't do something like this where you just make a line like that. We want it to extend the whole graph. Alright, on to number 37. Y equals x. Now this line is just so simple that it might be confusing. Another way that you could write this out is y equals 1x, and then I don't see a y-intercept. Well, that means it's 0. So this line, you're actually going to start at the origin at 0, and your slope is 1, as in 1 over 1. It's positive. So you're going to go up 1 over 1, up 1 over 1, up 1 over 1, so on. So this is like a perfectly diagonal line. You can go back down the other way and fill those in. And so when you draw your line, again, use a straight edge, so your lines should look better than I'm drawing. That's what you get. That would be our answer. Alright, we have some more writing of equations, and so we're going to use either slope-intercept form, y equals mx plus b, or point slope form, y minus y1 equals m times x minus x1. So let's see what we got here. Write an equation of the line that passes through 5, 4 and is parallel to this line. So this line has a slope of 2, and we want our line to be parallel. So the only information we're going to use is that we want a slope of 2, and we want to use the point 5, 4. Once you know that, you don't need this line anymore. Sometimes people get confused and they do something with that line. You really don't need that information anymore. We got what we wanted out of it, and now we don't need it. So 0.54, slope is 2. So I'll go ahead and just plug this into point slope form. You got to do it one way or the other. So I'll do y minus 4 equals 2 times x minus 5. So that's going to be y minus 4 equals 2x minus 10. And then add 4 to both sides. And so my answer is y equals 2x minus 6. So that line passes through 5, 4, and it's parallel to this other line. But this is a different line. So the only thing we used this line for was its slope, and then we didn't need it anymore. Alright, number 39. Write an equation of the line that passes through 2, 8, and is parallel to this line. Alright, so again, if it's parallel, it's going to have the same slope, and that slope is 1/2. So this is all the information that I need. I don't need this line anymore. I'll do this one using slope-intercept form, y equals mx plus b. So my y is 8, My slope is 1/2. My x is 2, and I don't know what b is. Alright, so 8 equals 1/2 times 2, which is 1, plus b, subtract 1, and b equals 7. So now I know my slope, I know my y-intercept, I can write my answer. Y equals 1/2 x plus 7. Alright, on to number 40. Write an equation of the line that passes through 3, 1 and is perpendicular to y equals 1/2 x plus 10. So perpendicular, our slope's not going to be 1/2. It's not going to be the same. It's going to be the opposite reciprocal. So if you look at 1/2, the opposite of that is negative 1/2, but then we also want to flip it. So it'd be like negative 2 over 1. I'm just going to simplify that to negative 2. So this is the information that we're using. We don't need this line anymore. I'll just go ahead and plug this into point slope form. So y minus 1 equals negative 2 times x minus 3. Alright, so on the right side I'll have negative 2x plus 6. Then I'll want to add 1 to both sides, and I get my answer. Y equals negative 2x plus 7. Alright, number 41. It's another perpendicular one. Write the equation of the line that passes through 3, 8 and is perpendicular to this line. So what's our slope going to be? Well, we want it to be opposite reciprocal. So their slope's negative 3/2. Ours is going to be positive 2/3. And again, once you know that information, you don't need their line anymore. I'll do this one using slope-intercept form, y equals mx plus b. So my y value is 8, my slope is 2/3, x is 3, and I don't know what b is. It's like, I already know my answer is going to be y equals 2/3 x something, I just don't know what that b will be. So 8 equals, let's see here, 2/3 times 3 is actually just 2. And then subtract 2 from each side, and b equals 6. So my answer, y equals 2/3 x plus 6. Alright, let's take a look at these last two examples here. Number 42, in the diagram, CD is perpendicular to FG, and we know that. We can see the perpendicular marking. Find the value of x. Well, we learned a theorem that says that if two lines are perpendicular, all 4 angles formed are going to be right angles. So this is a right angle. It's going to add up to 90 degrees. So I'm just going to put that into an equation. 5x plus x, those two angles together equal 90 degrees. 5x plus x is 6x. So 6x equals 90. Let's divide that by 6. And 90 divided by 6 is 15. So that is the answer. Number 43, in the diagram, these lines are perpendicular. This is very similar. If they're perpendicular, that means all 4 of these are going to be right angles. So those two angles, 75 and x plus 8, those are going to add together to equal 90 degrees. 75 and 8 makes 83. And if you subtract 83, we get x equals 7. Alright, well I hope that makes sense. Good luck in studying for this test. I'm glad to help you however I can.